Good morning. In today's session, we have to start our fourth unit, that is the operational amplifier. We can say operational amplifier as a op-amp. These are the contents which we are supposed to study about op-amp. We will wait for other students for 1 minute, then we will start our today's session. प्रणाली, आवाज आ रही है अच्छे से? स्क्रीन दिख रहा है?
Yes, ma'am.
Okay. So here we are supposed to study about op-amp, its circuit symbol, then we can see its pin diagram, why we will require the op-amp, its ideal characteristics, non-ideal op-amp, characteristics of op-amp, its advantages, disadvantages, and some applications. So what we are saying about the op-amp, op-amp is nothing but it is an amplifier. By proper selections of its external components could be configured for variety of operations. Because by using the operational amplifier, what we can do, we can increase, we can amplify voltage or the current value. It means what? We can improve the energy sources by using the operational amplifier. If you see about the history, operational amplifier was first developed by John R. Radzin in 1947 with vacuum tube. But in 1960, it is again discovered by Fairchild Semiconductor Corporation Robert G. Wilder. He fabricated op-amp with the help of IC fabrication technology. It means what? He has declared we can make the IC to work as a op-amp. Again in 1968, the Fairchild introduces the op-amp that was used in the industrial standard. It means what? He again added some specifications to that op-amp, so it was used in the industry also. If you see the circuit diagram, the symbol for the op-amp, it will look like this. It is a two-terminal input. It means what? If you see for the op-amp is a DC coupled high-gain electronic voltage amplifier. There are different types of the op-amp. The direct coupled high-gain amplifier usually consists of one or more differential amplifier. So what does it mean by differential? If the amplifier is giving the differences between two inputs, as the name defined, differential, there is a difference. At that time, we can say that op-amp as a differential amplifier. So here, this is the symbol for the op-amp. Output stage is generally a push-pull or the push-pull complementary symmetry pair. Like we have seen in our first unit, MOSFET analysis. At that time, we have seen the different types of inverter, push-pull complementary symmetry. At that, here output state is also like a push-pull complementary symmetry pair. And we are having the op-amp that are differential amplifier, and their output voltage is proportional to the, it will be proportional to the difference between input voltage. And the systematic symbol is shown in above diagram. The two input terminal called as, if you see here, we are giving the two inputs terminal. One is negative terminal, one is positive terminal. So in between these two input terminal, we can say negative input terminal as a inverting, and we can say positive input terminal as a non-inverting input terminal. These are labeled with input. Inverting is labeled with negative sign, non-inverting is labeled with positive sign. So we are saying this is the circuit symbol for the op-amp. This is the general purpose op-amp. We are supposed to study about the differential, dual input, balanced. We will see one by one. So here, this figure shows the symbol of the op-amp and the power supply connection. It means what? Here we are giving the power supply. This is the symbol we have seen. This is the symbol for the op-amp. When we are giving the supply, you can see here, we are giving the supply. So here I have shown the positive supply terminal and the negative supply terminal, because if you see here, we are giving positive and here we are giving the negative input terminal. So here we can connect the power supply to this op-amp to make it work. And here we are defining the input terminal, inverting and the non-inverting. Negative input terminal we can call as the inverting input terminal, and we can call positive input terminal as a non-inverting input terminal. Again, we are aware about the Vn and Vp. These are nothing but, if you see here, we are giving here negative voltage. So we can say this is as a Vn, and Vp is nothing but it is the voltage that will be positive. So here, if you see, their voltage with respect to ground are denoted as Vn and the Vp. Vn is nothing but negative supply and Vp is nothing but the positive supply. Okay. What again we can say here, and here we will get the output that is nothing but VO, output voltage. Op-amp do not have a 0-volt ground terminal. Ground reference is established externally by giving the supply that is nothing but commonly. It means what? We can give here power supply commonly, which will give us reference ground voltage. If you see how it will look like practically. So here I have shown its symbol, what an op-amp looks like in today's world, because we have seen op-amp was discovered in 1968, which we can use in the industry, and he has given in the form of IC fabrication. So here you can see it will look like this. This is the op-amp. This is the pill brick operational amplifier. There are different types of op-amp. So firstly, we will see about the pin diagram of op-amp, and here we are having the general common op-amp. That is nothing but we can take one example as a IC741. It is also a type of op-amp which is used in many instructional courses, and it is having 8 pin. If you see LM34, LM741, LM741, this is the 8 pin IC. Here, if you see, there is some knot, half circle here shown. So from the left side, we can start 1 to 4, again 5 to 8. So here we can say about the pin diagram of IC741. It is having 8 pin. Pin 1 is reserved as offset null. Pin 2, we can give here negative input. So we can say it is the inverting input terminal. At pin 3, we can give non-inverting input. So we can say that pin as a non-inverting input terminal. Again, pin 4. We can say pin 4 as a minus VCC. It means what? Here we can give negative power supply, and at the pin 7, we can give positive VCC. It means what? Positive power supply. Again, like one pin, fifth pin is also reserved as a offset null. At pin 6 we can get the output. मतलब 2 3 को हम इनपुट दे रहे हैं और at pin 6 we will get the output. Pin 8 there is no connection, so we can write not connected, no connection. So this is the pin diagram for IC 741. Now we are supposed to study about the different parameters which we are supposed to use in the op-amp. So what we are saying here, when we are supposed to use amplifier. At that time, in our syllabus, we are supposed to study about the differential operational amplifier. It means what? We can say difference amplifier. It means what? Here we will get the output that will depend on difference between input voltage. So here if we are giving the 2 volt, 2 terminal voltage, negative terminal voltage, positive terminal. So we can call VD as the difference between the voltages. That is nothing but Vp minus Vn, positive minus negative. We can call A is nothing but the gain. How we can calculate the gain? We can calculate the gain. It is the ratio of output voltage upon the input voltage. We are having output VO, we are having input Vp minus Vn, because we are saying here the difference between input voltages. So we can take Vp minus Vn. So we will get gain A equal to Vo upon Vp minus Vn. You can rearrange that equation in the form of Vo. So here we are supposed to study about the parameters. So here input bias current. This is the average of current that is flowing into the inverting and the non-inverting input terminal of op-amp. So what we are saying about the biasing? Biasing nothing but when we are giving the external supply. So what we are supposed to study here? Input bias current. So that is nothing but it is the current. Which current? Which is flowing through the inverting and the non-inverting input terminal. So we can say input bias current as it is defined as it is the average of current that is flowing into inverting and the non-inverting input terminal of op-amp. Again, what we can say about the input and output impedance? These are nothing but the resistances. So it is the resistance which is offered by input, that will be the input impedance, and the resistance which is offered by the output terminal, that is called as the output impedance. These resistances are used to vary the voltage because we are aware about the Ohm's law and we have seen V equal to IR. So if we are changing the value of resistance, we can vary the voltage. So we can say it is the resistance offered by input and the output terminal to vary the voltage, and we can calculate input and output impedance by using the unit ohms, because we are calling the impedance as a resistance. Now we are supposed to study about the gain. Gain is nothing but open loop gain. Here we are using the operational amplifier that is used to amplify the voltage. So here about the open loop gain, we can say it is the overall voltage gain, or we can say it is the amplification. Now, input offset voltage. It means what? It is the voltage that is applied between two terminal of op-amp when we are setting the op-amp to the null point, because we have seen 4 number pin. We have seen here the 4 number pin, one number, sorry, not a 4, the 1 number pin and fifth number pin. We are reserving here as a offset null. So here we can say when we are not connecting this to anything, it means what? If it is a voltage that must be applied between the two terminal when op-amp is set to the null output, at that time we can say that input voltage as a input offset voltage. Again, input offset current, it is nothing but it is the current, it is the algebraic difference between the current that is in between inverting and the non-inverting terminal when op-amp is set to null output. Now we can see about the ideal op-amp. We are using the op-amp to increase the amplification. It means what? To increase the value of voltage. So we can see here, we know that to minimize the loading, a well designed voltage amplifier must draw negligible current from the input source, and there will be negligible resistance at the output load. So we can say op-amp are having no output voltage exception. So we define the ideal op-amp as an ideal voltage amplifier with infinite loop gain. What we are saying about the gain, we can denote gain by letter A. So we can say when we will get the amplifier gain that is infinite, we can say that op amp as a ideal op amp. And here we are supposed to minimize the loading. It means what? We will get the negligible resistance at the output. So here we can see its ideal terminal conditions are we will get output resistance 0, input resistance infinite. We will get input IP and IN current that are nothing but the 0 ampere. Ideal op amp follows the given property. These are nothing but it is having infinite voltage gain. We can denote infinite voltage gain by letter A. So we can say it is having infinite A. It is having infinite input resistance. We are saying here we are using the differential amplifier. So we can say infinite input resistance is nothing but the difference between the resistance between the input terminal. We can denote that input resistance by letter RD, so that almost any signal source can drive it and there is no loading of the preceding stage. Here we will get the zero output resistance if that op amp is a ideal. So that we can drive the output that will have infinite number of other devices. We will require the zero output voltage when there is no input, or we can say when there is input as a zero. So what we are saying here, it will have zero output voltage when there is a zero input. It will have infinite common mode rejection ratio, CMRR. These are the parameters we are supposed to study. We will see in the next section. Now here only we are supposed to study about the symbol, the characteristics, advantage, disadvantage, applications of the op amp. So what we are saying, we can say op amp as an ideal op amp if it is having zero output resistance, infinite input resistance, infinite voltage gain, zero output voltage if there is no input. Again, we can say it will have infinite CMRR. There will be the question on MCQs. It is having the infinite or zero CMRR like this. It is having infinite slew rate. We will see these things in next session. We are supposed to see these things thoroughly so that output voltage changes simultaneously with changes in the input voltage, because we will get here infinite CMRR and infinite SR. This is nothing but slew rate. Now, we are supposed to study about the non-ideal. So here if you see at the output we are connecting the voltage divider circuit. So here this is the opposite to the ideal op amp. In our op amp ideal, what we are saying, we will require output resistance 0. So here output resistance will be infinite. Again what we are saying here, there we will require higher voltage gain. तो यहाँ पे क्या होगा, gain का value कम होगा. So here we can say non-ideal op amp is exactly opposite to the ideal op amp. Only the positive and negative terminal are changed their positions. There is a single input external supply. Here we are giving the single external input signal, that is the positive. We can say that voltage as V1 equal to V plus, that is the positive that is applied to the positive pin of the op amp. but there we are connecting positive and input both terminal for the voltage. And here a signal is also made to appear at the negative input terminal, but this is derived from the resistance R1 and R2. If you see here, we are connecting output again to the input. So we are taking the negative input voltage from these resistors. We can see here a signal is also made to appear at negative terminal, but it is derived from resistances, voltage divider circuit. And positive we are giving directly by using the external supply. So this is the circuit diagram for the non-ideal op-amp. Now we are supposed to study about the different characteristics of ideal op-amp. We have seen if we are supposed to use op-amp as an ideal, we will require infinite input impedance. That is nothing but we will require about 2 mega ohm. Low output impedance, that is about 200 ohm. We will require very large output gain at the low frequency. Thus, their small changes in the voltage can be amplified by using an op-amp. Again, we will require infinite CMRR, infinite slew rate, or we can say infinite power supply selection rejection ratio. Slew rate means what? We can say as a power supply rejection ratio. Again, we will require as a ideal op-amp characteristics, infinite bandwidth. There are different characteristics of the non-ideal op-amp. These are exactly opposite with the ideal op-amp. Here we will require gain that will be finite or that will be zero. That will causes gain error. Here we will require finite input impedance and non-zero output impedance. Exactly opposite. वहाँ पे infinite CMRR था, यहाँ पे finite CMRR. Common mode rejection ratio. Common mode input resistance. Again, it will there infinite bandwidth. Here we will require finite bandwidth. Here we will require finite slew rate, that is nothing but finite power supply rejection ratio. Now we can see some applications of the op-amp. These are nothing but we can use op-amp in the analog to digital converter, A to D converter. We can use in the power source. We can use op-amp in the zero cross detector. So we can see here analog to digital converter. When we are using DAC or ADC, that means digital to analog converter, or we are using analog to digital converter. These are the building blocks with the interface sensor. So here if we are using the ADC, it will take analog signal and it will convert that signal into digital. That is nothing but the binary one. So while DAC converts binary to analog, here we can see the block diagram for the ADC, digital processing system with the ADC at the input and DAC at the output. So here we are using the input, that is nothing but analog. If we are telling anything at that time, these signals we can take analog, we can use the digital system that will convert that into a digital, and we can again convert that into a analog by using the DAC. So here we can use the amplification to increase the value of sound. So here op-amp as a current source. Current source can be made Current source can be made from inverting amplifier as shown in figure. If you see here, we are giving the output to the input by using the resistance. We can say that resistance as a feedback resistance. And we are giving to the inverting terminal. So we can say the circuit as an inverting op-amp. We can use that op-amp circuit as an inverting amplifier to work as a current source. Here, the current in the load resistance, that is nothing but output resistance RO, that will be equal to the current that is flowing in the resistance R. So here we can calculate the current that is obtained by dividing the input voltage by resistance R. I equal to V by R1. Zero crossing detector application, because we are saying here we can use op amp into A to D converter, power supply, zero crossing detector. That's why we are supposed to see these applications. Zero crossing detector applications, we can say this as a JCD, zero crossing detector circuit. We can be use that to check whether op amp is in good condition or not. It means what? If we are using the zero crossing detector, this can be used as the frequency counter. Also, we can use for switching purposes in the power electronic circuit, because the ACD is also a basic amplifier circuit, and the circuit diagram for the zero crossing detector will look like this. Here we are using the IC741. Here we are giving the supply to the positive terminal, and negative terminal is directly grounded. We can see some advantages of the op amp. Op amp is an universal amplifier. We can use op amp as an analog to digital converter or digital to analog converter filter. We can use op amp as a voltage comparator, precision rectifier, analog to computers. We can use this as a differentiator, integrator, voltage and current regulator. If you see, there are some disadvantages of op-amp. These are like most op-amp are designed for low power operation. For higher output is desired, then op-amp specially designed for that purpose must be seen, because we are saying here op-amp is giving the low power operation. So if we are supposed to increase the output, we will require the special design op-amp. And most commercial op-amp shuts off when the load resistance is below the specific level, because we are saying we are supposed to get finite or the zero output resistance. That's why we can say here this is the disadvantage for op-amp, because most commercial op-amp shuts off when it is having load resistance that is below the specific level. So here we have finished about the advantages, disadvantages, applications, characteristics, ideal, non-ideal op-amp. We are supposed to study op-amp thoroughly. We will see remaining syllabus in our next session. If anyone is facing any issue, you can ask me. If you guys have not finished your assignment, then please finish your assignment and submit. You all are supposed to join class again on 9:45 for electrical circuit. There will be class. Here we have seen about the op-amp. We can say op-amp which we can use to amplify the value of voltage signal. Op-amp is discovered in 1947 by John Razine. Again in 1960, Fairchild Semiconductor Robert J. fabricated op-amp with the help of IC fabrication. And in 1968, he introduces the op-amp that can be used in the industrial application. This is symbol for op-amp. Here it is two-terminal input. It means what? Here we can give positive input to the positive terminal, that we can say as a non-inverting input terminal. Negative we can say as a negative input terminal. सुचिता थीटे क्लास फिनिश होने आ रहा है और अब तुम ज्वाइन कर रहे हो. Okay. हाँ. So here what we can say about the negative input terminal, we can say that terminal as a inverting. So if we are giving here, that will be inverted at the output. And if we are saying that op-amp as a differential amplifier, at that time output voltage will be depend on the difference between this input terminal voltage. So we can say op-amp as a differential amplifier when their output voltage is proportional with the difference between input voltages. And the system schematic symbol for the op-amp is shown above. Again, we can see here if we are giving the positive supply to the positive terminal and negative supply to the negative terminal. At that time, what we are saying here, we are supposed to give the supply, but how we will give when we are connecting here negative terminal? You can see here, when we are using the op-amp which is having the two terminal input, at that time we are giving the positive supply here. जहाँ निगेटिव है वहां पे हम पॉजिटिव दे रहे हैं और जहाँ पॉजिटिव टर्मिनल कनेक्टेड है वी आर गिविंग हियर नेगेटिव सप्लाई सो वी कैन गिव द supply power supply to the op amp that will be look like this. Here we are giving the negative input, here we are giving the positive voltage, and if we are supposed to give the VCC that will be positive and negative, we can give positive supply here and we can give negative supply here. Again, if you see the symbol for the op-amp, how it will look like practically. So it is IC. This is nothing but LM358. It is the 8-pin IC. So here we can see the pin diagram. IC741, this is the common general purpose operational amplifier. It is the 8-pin IC. First pin number is reserved as optional as well as 5-pin number. Again, at the pin 2 and 3, we can give the input. At pin number 6, we will get the output. At the pin number 4, we can give negative supply. At the pin number 7, we can give positive supply. And at the 8 pin, there will be no connection. So we can say that pin is not connected to any terminal. Now we are supposed to study about different parameters which we are supposed to use in the op-amp. So here we are saying we are supposed to use the op-amp. That will be the differential. It means what? Output voltage will depend on the difference between input voltage. So we can say we are having the two terminal input voltage. So that positive input and the negative, or we can say inverting and the non-inverting. Vn means what? Negative voltage. Vp positive or non-inverting voltage. So here gain we can calculate as it is the ratio of output voltage with the input voltage. So we will get output voltage equal to gain into Vp minus Vn. These are some parameters we are supposed to use in the op-amp. So here we are saying we will require op-amp that will be ideal at that time. Its input resistance will be infinite, its output resistance will be zero, its input positive and negative current will be zero. It will require higher bandwidth. Its gain will be higher. So these are the some characteristics, some properties which we will require to use op-amp as a ideal. It will have infinite voltage gain, infinite input resistance, finite or zero output resistance, zero output voltage if there is no voltage, input voltage, infinite common mode rejection ratio and infinite power supply ratio, that is nothing but the slew rate. If we are supposed to use op-amp, that will be non-ideal. At that time, we are giving positive supply externally and we can get the negative supply from the output from the voltage divider circuit. Here we can calculate gain equal to 1 plus R1 by R2 because here we are using the voltage divider circuit at the output. These are some characteristics for the ideal and the non-ideal op-amp. Non-ideal op-amp will have the characteristics that will be exactly opposite for the ideal op-amp. There are the applications of op-amp like it can be used in a analog to digital converter, power source, zero crossing detector. We are using the ADC at the input to convert analog signal into the digital. If we are having the digital data and again we are supposed to convert into analog, we can convert by using the DAC and here we can use the op-amp. Op-amp as a current source. we can use op-amp as a current source. If we are supposed to use op-amp as the current source, at that time we can use op-amp that will be inverting op-amp. So here we will get the current that is flowing through the load resistance. That is nothing but RO. That will be the current flowing through the R1 because these are connected in the series. Zero crossing detector application. If we are supposed to use the IC, that will be the zero crossing detector. At that time, we are supposed to check whether the op-amp is in good condition or the not. Zero crossing detector can be used as the frequency counter, or we can use that for the switching purpose in the power electronic circuit. Here we can see some advantages of the op-amp. We can use op-amp that can be used as the universal amplifier, voltage comparator, precision rectifier, analog to digital, digital to analog converter, differentiator and the integrator, voltage current regulator, analog to computers. There are some disadvantages of the operational amplifier. These are nothing but most op-amp are designed for the low power operation. And if we will require the higher output at that time, we are supposed to design that op-amp by using the special specification. So we can say for higher output, if we will require the higher output from the op-amp, at that time op-amp specifically designed for that purpose. And most just wait for me. And most commercial op-amp shuts off when the load resistance below specific level. Remaining syllabus we will see in the next session. Now I am taking you a 10. You all are supposed to join the class again on the 9:45 for the electrical circuit. Okay, we can leave now. Thank you.